Hi, good evening. Hi, good evening to all. Welcome to our podcast tonight. And anyway, tonight actually, I wish to probably share with you guys a very interesting topic, which is consensus. Okay, so before I go on to the topic for today, probably I would like to share some personal opinion over to the crowd uh, for tonight's podcast. Because some might find that the podcast Crypto 101 is a little bit boring. It's not related with UBX or anything about investing. But probably I would like to say is because investing is actually not more than just putting money and expect returns. It's actually all about knowledge, strategy, and long-term growth. So in UBX Academy, we are actually committed to build an education center where investors can develop the right mindset, gain real insight, and make informed decisions. Learning is the foundation of successful investing, and we want to empower every individual and all our listeners with all the skills and understanding that is needed to navigate in the crypto world and also in the financial world with confidence. So tonight we are actually going to explore one of the most fundamental aspects of blockchain technology, which is the consensus mechanism. So these mechanisms are actually the backbone of decentralized network, ensuring security, efficiency, and trust without the need of any central authority. So before we begin, let us go around and take a look what is the most basic consensus mechanisms I believe most of you have heard before, which is the proof of work or the proof of stake. So, but maybe a lot of people will ask what exactly is consensus mechanism? Let us deep dive into it. So, it's actually a method used in blockchain network to achieve agreement among distributed participants. So in simple terms, it's determining how transactions are validated and added into the blockchain. So this is a crucial for maintaining the integrity and the security of the network. So let me give you a good analogy. What is consensus mechanisms? So just imagine there's a group of friends deciding where to eat. Without a leader, they must agree collectively, ensuring fairness and transparency, much like a node in the blockchain. So let us take a moment to think about why achieving consensus is so important in the decentralized system. Just think that what would happen if there is no rules in place for agreement? Would you actually trust the financial system where anyone could add transaction at will? I believe no one would like to have that kind of financial systems in place. But do you know why is it important for consensus mechanism to be in the blockchain? So in traditional financial systems, like a central authority like banks verify central the transactions. But in the blockchain, there is actually no central authority instead. Consensus mechanism help nodes in the network agree on the state of blockchain. So they actually serve three main purpose. So security. So it can actually prevent miraculous attack like double spending, and also transparency, ensuring that all transactions are actually recorded and auditable, creating an immutable record for all network activity. So every participant can verify transaction independently, ensuring complete traceable and accountable in the system. And also decentralized, maintain the blockchain decentralized nature, preventing any single entity to be in control. So it can distribute power across thousands of nodes worldwide. No single entity can modify the blockchain without consensus from the network, ensuring a true democratic governance. So there are actually multiple type of consensus mechanism, but naturally, most of us actually heard a few of them, which is the proof of work, the proof of stake, and also probably some the proof of authority. So let us go deep down into our first proof of work, the original blockchain consensus. So it involves solving complex mathematical problem requires significantly computed power. So it's also actually the first node to solve the problem, get to add the next block to the blockchain earning rewards. So when a miner successfully finds a nodes that produce a hash below the target, they win the right to add a new block and receive the tokens. So our first blockchain consensus that uses the proof of work, I believe most of you or most of us know it, which is the BTC, Bitcoin. But for more computation power a node has to, to actually solve problem and earn rewards, it actually consumes a lot of electricity. So with success rate proportional to the miner computational power, a lot of large mining farm actually spends on consume almost 100 terawatts of electricity annually. So Bitcoin actually is one of the proof of work. Bitcoin miner actually can complete to solve cryptographic puzzles require massive computational power. So each miner actually attempt to find a special number where combined with the transaction data to produce a hash, which is we call it as the hashtag. So this process requires millions of calculation per second. But for those actually uh, produce the computational power, actually will also receive rewards. Successful miners currently actually can receive up to uh, receive bitcoins actually plus transactional fee. So this kind of block rewards will always have approximate every 4 years, creating scarcities in Bitcoin. So miners will be incentivized to maintain this network using the proof of work. So mining, hash, and network security are actually found in the proof of work. Miner actually can complete the hash value by testing billions of random numbers per second. So this kind of computational require powerful computers we call as ASIC. So each block is secured by linking it to previous block through the crypto hash. Changing every single transaction would require redo of all the computational work for all the blocks and also all the subsequent blocks. So there are more miners in the network which create more security. So with almost over 1 million active miners worldwide contributing computing powers to the network itself, the network require a control of 51% of total mining power. So let's take a look. So there are limitations of proof of work. What are the limitations? Which is actually much energy consumptions. Bitcoin mining alone consume more electricity annually than an entire country for those that is not mining Bitcoin. So this massive energy usage result in a significant carbon footprint, which each single Bitcoin transaction consume enough energy to actually power averagely a normal household in USA for almost up to 75 days. So it's also have a scalability limitations. It's actually increasingly difficult for of mining algorithms require because more computational power over time. Miner actually need specialized hardware costing probably more than $10,000 per unit. While the network can only process 7 transactions per second, far below needed for global adoptions. But somehow Bitcoin stands strong in tokens due to its scarcity. So many networks have come to try to solve the problem, like Ethereum. Ethereum has also grown to solve this network issue, which actually slowly they have upgraded themselves to proof of stake. So let us take a look at what is proof of stake. It's actually a more energy efficient alternative. So in the proof of stake, validators, probably, let me take an example of the Ethereum. A validator must actually stake minimum of maybe 32 Ethereum as a collateral, which can be stashed if they act miraculously or validate incorrect transactions. So a lot of Ethereum holders, they actually do validating. They require to do staking with the proof of stake. So validators are actually choose randomly based on the amount of cryptocurrency they have staked. So major currency like Ethereum and Cardano uses this system where validators can earn 4 to 10% annual returns in their stake asset while helping to secure the network. So how proof of stake validate transaction? Probably we need to get the idea of it. To become a validator in the network, participants must actually stake a specific amount depending on what network they are. So in this reference, I'll take an example of Ethereum. So Ethereum uses a weighted random selection process. For example, someone stake 320 Ethereum has 10 times higher chance of being selected than someone staking 32 Ethereum. So this is how they actually assign the validators. So transaction validations, validators verify transactions and add them to the blockchain, earning reward for their works. So they are there to actually do a double check for any double spending and also validate smart contracts and ensure the network rules are followed. So successful validations earn approximate 4 to 10% in APR in rewards, while the dishonest behavior risks losing their entire staking. So just imagine 32 Ethereum, probably approximate 50 over 1,000. If validators were to actually do any uh, unrightful or dishonest behavior, they might lose the whole staking amount. So I believe most of us know that actually Ethereum was used to be a proof of work. They have mining machines as well and also consume huge electricity or energy. So Ethereum completed in the transitions to proof of stake during 2022. This historical upgrade changed how transactions are validated, shifting from energy-intensive mining to a staking-based system. So this also helped to reduce energy consumptions with the proof of stake. So this transition actually allowed the mining of Ethereum dropping for at least from 100 over terawatts to just 0.01 terawatts annually. These dramatic improvements made Ethereum one of the most environmental sustainable blockchain perform. We also realize the transaction fee or the gas fee become as cheap than before after they have changed to proof of stake. So let us go on to the next consensus mechanism, which is the proof of authority. This is a reputational based validations. Unlike proof of stake, POA, which is proof of authority network, typically have 10 to 25 pre-approved validators who must verify in real-world identity and undergo rigorous vetting processes. These validators are often established institutions like banks, universities, or technological companies with significant reputable stake. So validators are chosen based on their reputations and track record. So they probably need to maintain their position through consistent performance and active behavior. They also must demonstrate almost 99.9% uptime response to security audit within 24 hours. So it maintain valid business credential. Any misconduct result in immediate removal from the validator set. So proof of authority, which is POA, is commonly used in enterprise and permissible blockchain. Enterprise settings like supply chain management, where pre-vetted manufacturers and logistic providers serve as trust validators. So these blockchains are typically private and controlled by a specific group of entities. They also probably used in most of the financial institutes and healthcare network being implemented in the private blockchain with strict access control, allowing only authorized members to validate transactions and maintain regulatory compliances. So POA actually prioritizes speed, security, and compliance over decentralization. This network can process thousands of transactions per second while maintaining security in the real-world business application. So next we have the proof of lapse time. So in this, actually validators must wait for randomly assigned time period before adding new blocks. So this creates a fair lottery system where nodes with longer wait time have a higher chance of being selected as the next block validators. The process typically takes 10 to 30 seconds per validation round. So it also uses this method leveraging the Intel software guard extension technology for secure and verifiable timekeeping. So within the processor, it able to ensure tamper-proof timekeeping. This trusted execution environmental prevent validator from manipulating their waiting time. So this also actually means consuming lesser energy than proof of work system. And this particular consensus mechanism is popular in supply chain and financial service blockchain. So how they are being worked to validate in the network? Let's take a look. Validators nodes are selected through cryptographic random numbers generations and weight probability function. So basically, they are actually users being chosen to validate blocks in blockchain to ensure fair distributions of validation right across the network. So this randomization prevents centralized by making basically they are actually used to make computational calculations so that it cannot be manipulated even by any centralized organizations. So this actually reduces the rate of being attacked by hackers. So the leading example include proof of authority using trusted validators, and it also combine the use of proof of lapse and also proof of wake later I'll touch on. So the next mechanism, which is actually the proof of capacity, POC. This actually have the validators dedicated at least 100 GB of storage space to participate. The network currently uses over 500 bytes of combined storage capacity to maintain security through data redundancy. So they could complete solving cryptographic puzzle that require storage space, earning rewards for the contributions. So this mechanisms is actually using hard drive space as a validation tool. So proof of capacity consume very little energy compared to the proof of work. So it's very efficient. It can leverage existing hardware drive infrastructure, minimizing additional energy consumption. However, it actually requires large amount of storage space to participate effectively. So the barrel to entry require at least 5 terabyte of dedicated storage space to complete its efficiency, where optimum performance achieved at more than 50 terabytes of hard drive space. So let's go on to the proof of weight, POW. Validators are assigned weight based on amount of cryptocurrency they hold. So probably you might heard a lot of proof of weight in the consensus mechanism in most of the gaming platform, which validators receive voting powers proportion to the holding. So this create balanced system where largest stakeholders have more influentials while preventing monopolizations of the network. So in the block proposal using proof of weight, the protocol randomly select validators for block proposal, with selection probably try to stake weight. So this enable transaction finalized in less than 4.5 seconds while using only a fraction of energy compared to the proof of work system. So weight voting in blockchain networks are very commonly found in most of the metaverse projects. Proof of weight achieve transactional in less than 4 seconds by using token holding to determine the validator's influential. So this makes significant more efficient than traditional consensus mechanism. Weight voting also promotes in most of the decentralized network as no single validators hold the majority of the weight. So usually it has a capping for individual voting power, regardless of the total stake, preventing any single validators from the dominating to dominate the network. However, usually it will require a minimum stake to become a validator, potentially limiting participations that uses the proof of weight. So let us take a look. You guys might have seen this KYC term or biometric verification. So this proof of identity allow validators are verified through know your customer procedures and biometric identifications. So some platform actually uses this proof of identity to to allow verification through government issue ID. Some actually uses facial recognitions. or even fingerprint authentications. So this multi-factor approach includes video verifications. So this prevents identity fraud in the Web3 world. So this approach actually strengthens the security by linking validations right to the real world identities. So all validations and transactions can be traced to the real world entity, enabling rapid fraud detections while maintaining the public ledgers. So let us take a look at the biometric and KYC based consensus. How does it work? So network security and trust are enhanced through KYC procedures and biometric identifications, including facial recognition. So when we actually think about the decentralizations, many might not like this KYC, but some of the projects or platform require KYC due to the sensitivity. Many actually uses this decentralized platform or network to provide or store sensitive personal data and biometric information on the chain. But with this KYC, it makes a lot of users have to be able to be identified in the Web3 world. So this might be some concerns to individuals about having privacy and data protections. So this become challenging to implement on in a global scale, especially whereby a lot of users wanting to be hidden behind in the decentralized world. So if you guys realize why some centralized exchanges require us to do a KYC, the reason being is when we actually do a lot of withdrawal or transactions, if the exchange knows that who is actually using this particular wallet, there will be lesser chance for the hackers to be taking money out from the exchange. So subsequent in the UBX account, most of the users would need to do KYC consensus mechanism to actually operate on their individual account. But at the moment, if you realize we do not require KYC for all accounts, but this is a very important consensus mechanism to prove or to show a lot of developers on our account database so that we have a very huge big data to provide user data to provide to our potential investors to join into our UBX platform. So next, we also have this very important mechanism in the consensus, which is the proof of burn. It's a way cryptocurrency is being destroyed to have a limitation in the supply. So how this work? Validators actually send their tokens to a specialized burn address where cryptocurrency are permanently destroyed. So during this process, validators are sacrificing real assets to burn in the network. So the burn tokens are usually verified on the blockchain, creating a transparent record of participations. So each burning event permanently removes tokens from the circulations, creating a natural scarcity with a fixed or decreasing supply. Remaining tokens may be appreciated during this process. So this mechanism also help prevent inflations and incentivize earlier network participations. So in UBS, if you notice, we uses the burning mechanism as well. The proof of burn, how is it being done? Which all our, if you notice our tokenomics, all our tokens that is used in the transaction fee and the quota limits during a period of time, company will actually use the proof of burn to destroy the tokens that is being used as the quota limits and also the transaction fee. So in total, UBX has a 30% of token that will be destroyed, which will actually improve the scarcity and allow appreciation in the token value. So token burning is also a kind of strategic consensus strategy. So it's a unique approach that incentivizes validators to invest in the network. So this is a costly process, potentially discourage small participants. But if we look into a long period of time, with this consensus strategy, it allows the tokens to appreciate due to its scarcity. So in this way, actually, you can see that unlike proof of stake, where tokens can be unstaked, burn tokens are permanently removed from circulations, resulting a irreversible capital loss for validators. But it is a must for such strategic move because it will improve the value of a specific tokens. Okay, so this delegated proof of stake is a kind of community voting. So token holder that participates in the voting systems, each can influence proportional to their staking. So top rank validators earns the right to validate block and receive transaction fee as a reward. So this create a representative democratic model within the blockchain network. So proof of stake, the delegated proof of stake, which in short we call DPoS, is allow for decentralized governance, empowering users to decide on network directions. So stakeholder can propose and vote on critical protocol changes, including transaction fee, blockchain sizes, and also the rewards. They are the group that maintain the network security by having power to vote out underperforming or malicious validators. So let us take a look at the elected validators in blockchain network. So DPoS are usually promoted widely in communities participations in blockchain. It can be vulnerable to attacks on voting system, leading to centralizations of power. So it also have it can be difficult to ensure fair representations of different groups within the community. So the proof of stake, and there is actually a difference between the proof of stake and the dedicated proof of stake. So the main difference is actually how the validators are governed, do the governance of the work. So just now we mentioned that proof of stake validators can choose based on the number of tokens they stake. So the more the user stake, the higher the chance of being selected. But for DPoS, token holders are actually being dedicated, are being selected. This small group of validators are being selected by the centralized uh, network who are responsible for validating all the transactions on behalf of the network. So we can actually have a thinking of POS as the democracy where everyone who stake tokens get the proportional stakes in the validations, and where the POS is the representative democratic, where token holders elect a small group of trusted representatives to validate the transactions for them. So we come to the proof of history, which is actually a consensus mechanism that used by Solana. So this actually gives a verifiable delay function that created subsequent hash chain record of the passage of time. This cryptographic mechanism generates timestamp that cannot be manipulated or forged. So this method actually uses ensure fast and reliable block validations, enhancing the network performance. So by pre-computing transaction timestamp before consensus, Solana dramatically reduce block validations. So validators can instantly verify the chronological orders without complex synchronizations. So this proof of history is a very unique approach that addresses the challenge of timekeeping in blockchain network. So while highly efficient, the system relies heavily on leaders nodes with specialized hardware requirements, making potentially easy to be targeted by a lot of attackers. So it also has a complexity that makes it challenging for small node holders to participate. Because of the computational demand, it required limited participation from nodes holders with standard hardware. So this actually has a very great impact on being a decentralized network. That is why most of the consensus uh, we have to use a lot of hybrid to actually make into the network, blockchain network. For example, some of the projects actually can uses the POS, proof of stake, combining with the proof of uh, proof of weight, or there is also combination of proof of authority. So hybrid consensus mechanism can integrate with the proof of history as well, because it has the timestamping capability with a traditional proof of stake. So this approach actually allowed network to maintain the chronological ordering while ensure the security through stake-based validation. So while hybriding the proof of history, it can combine multiple validations network. Network can actually achieve up to 50 over 1,000 transactions per second while maintaining its decentralizations. So this also mitigate the timestamping vulnerability mentions in proof of history, while preserving the efficiency for using the proof of stake. Okay, let us take a look how the a lot of platform are using combinations multiple validation strategy. Network can actually use many different consensus mechanisms to combine to improve the consensus in the community of the network. So hybrid model can create more robust and resilient blockchain network. However, implementation challenge include coordinating different validator set, maintaining economical incentive across different mechanisms. So the future of blockchain consensus. So next generation consensus mechanism, we will actually slowly seeing a lot of AI assisted validations being emerging in the 2025. So while AI actually can help to validate with simple instructions, so this will build upon all the hybrid models that I mentioned just now to reduce network overhead by more than 40%. So, with the uses of different consensus mechanism, it can improve a lot of trust in the community or the blockchain network. So we have to understand consensus mechanism is the important foundations of blockchain. It can ensure security, decentralized, and efficiency. But also do take note, most of the mechanism has a trade-off, and the choice depends on the blockchain goal. Let us just imagine how a company works on the consensus mechanism. So company, just imagine for let us take an example of Google. Many might know Google actually has a very strong P&L, profit and loss. So user or probably the investor would like to buy Google share in the stock exchange. But not forgetting, normal users of Google, like you and me, do not have any benefit through the Web2 world. I believe most of us uses the Google functions or using browsers like Chrome. A lot of users provide a lot of database for Google, but Google do not pay off any single users. But have a second thought. If you have a share of Google and when it appreciate, you might actually have benefit from buying their stock. But what happened to those users in the using the Google? They do not have any privilege being using the functions from Google. But in the Web3 world, if you participate in any projects or platform, by providing consensus towards the platform, you are actually growing together with the platform. If the tokens that you hold, it can actually allow you to increase the value together with more consensus within the community. So many different blockchain technology in the crypto world require a lot of consensus from the community. And due to its decentralization, consensus mechanism is required to be in place so that it can be transparent to every single users in the Web3 world. So as we look into the future, The evolution of consensus mechanism will play a very crucial role in shaping the blockchain world. We need to see a shift towards energy efficient solutions and newer models or hybrid consensus mechanisms to increase or enhance the scalability. So looking ahead, blockchain technology is expanding beyond the financial world and entering into many different industries like the supply chain, healthcare, and even governing the blockchain. So we need to understand a lot of knowledge in the blockchain world to be able to identify many ecosystems or many seamless financial products in the Web3 world. So I hope today's sharing on the consensus mechanism allow you to understand how important these consensus mechanisms work in the Web3 world. I hope you guys find these sessions insightful. And I hope to bring you guys more Crypto 101 topic to you guys, and we can learn together in our next session. So tonight I have come to the end of my sharing and hope that we will bring more exciting podcast sessions to every single one of you. So thank you for staying with me, and I'll see you guys during our next few sessions of our podcast. Thank you very much.